Welcome, everyone. This is our 17th webinar in the Think CX Digital Leaders Tell All series. Evolv AI is an AI-driven solution for digital growth optimization that serves the best experience to each audience every time. Throughout the webinar, if you have any questions, feel free to put those in the chat area. If we don't address them on the call, we will certainly pick them up at the end via email. Before we kick off the discussion, I'd like to introduce our two panelists. Thanks for joining us, Kash Bennett. He is the Director of Product Management at Evolv AI. He works across software development, design, and marketing teams to deliver features that maximize impact for their customers. Prior to joining Evolv AI, Kash led product management and software development at WeWork, where he focused on building developer tools to help rapidly scale the business and create an excellent user experience for members. Thanks for joining us, Kash. And Rob Severn. He has over 10 years of experience in software development. He has led engineering teams at HP and Orasma, and currently at Evolv AI, he started as a developer, spent time in product, and now runs engineering. Thanks for joining us, Rob. All right, so let's go ahead and jump in. I will pass it over to both you and Rob. Thanks so much.
Thanks, Marion. And hi, everyone. Thanks for joining us today. Rob and I are going to review some essential concepts of artificial intelligence and machine learning. And we're going to review a traditional approach to digital customer experience optimization and personalization. And then we're going to discuss how each step in that process is being augmented and improved through the application of these technologies. So to start with, AI is a buzzword that's everywhere these days. And there are many different forms of this technology. So it's not always clear when a company says they do AI, what exactly do they mean by that? One of the key things to understand is that AI works best on problems that involve a large amount of data and or a large space of possible decisions. AI is much better than humans at keeping track of all that data, analyzing it efficiently, and quickly making a large number of small decisions. So here are just a couple of high-profile examples. You've probably heard of Alphago, which a few years ago, it beat the highest ranking Go players in the world. This was achieved in chess by IBM's Deep Blue in the late 90s, but the best human Go players were thought to be beyond the level of any artificial intelligence because there was a level of creativity and human intuition that was required to play the game. Well, clearly AI caught up. And what it comes down to is the sheer size of what we call the search space, which is the total number of possible moves that can occur during a game of Go, which at 10 to the 170th power is far more than the number of particles in the universe. And it's way beyond the capacity for any human to memorize or reason about. Similarly, customer experience optimization is a problem that involves a large number of variables and thus a huge number of possible experiences. By changing a relatively small number of different elements on a web page, for example, the search space quickly grows exponentially to millions of possible customer experiences. And this is just for a single web page. When you're optimizing across an entire funnel and different devices, the problem gets even more complex.
And so Kash's Go example described an algorithm that falls into the suite of algorithms that are called deep learning. So these are fantastic algorithms to use in cases where you have a large amount of training data. As the name training implies, this is how they build up their accuracy in making predictions. The more data they have, the better they perform at predicting outcomes. But AI is a very broad field of algorithms that extends far beyond just deep learning. For example, genetic algorithms is another type of algorithm that falls into that AI definition. Now, it's easily understood by anyone as they really just follow the rules of evolution, survival of the fittest. So In this example here, you can see that you start off with a population of individuals. And what's key with genetic algorithms is that you need a fitness function that describes how good that individual is at performing the task that you want to occur. So we use that measure of fitness in order to select the individuals. If somebody is high performing, then they are selected to continue on. If they're low performing, then we select them for culling and removing from the system. We can then take those individuals that have survived and use them to generate a new generation of individuals to test with. Now, we do that by taking the traits from those surviving individuals. That's a great way of driving performance to select for just the good traits that will push your performance in the measure of success that you're using. Now, there's one final thing that comes in with this algorithm, and that's mutation. So in order to allow you to successfully explore a space, mutation comes in with a random change to an individual that will allow it to see if that mutation is any good. That's what allows for significant jumps in performance. They're not always good, these mutations, but the process of natural selection will pick the mutations that work and bring them into the system more and more prevalently. So with this technique, it's a fantastic algorithm for starting off with no data in a really, really large search space. It's great for exploration in search spaces, especially that are not continuous. Now, what I mean by that is that if you change one particular feature of an individual, it can have a very large impact on their performance. For example, in this case that you're seeing here of teaching a robot how to walk, if you were to shift the center of gravity slightly to the left, then this robot's fitness function, which is its ability to successfully walk from point A to point B, will be massively impacted. So as you can see, these two kinds of AI are very different in profile, how they act, and the cases where they are successful and unsuccessful. So it's really important to be clear about the use case of exactly how you're trying to apply AI and what problem you are solving with it.
Right. So the problem that we are trying to solve is improving the customer experience in order to drive uplift in the KPIs that you care about. So these KPIs could be conversion rate or revenue or engagement or some weighted combination of goals. But the point is that in order to validate your results and to learn about what's working, you need a strong practice of experimentation. This is effectively bringing the scientific method to the world of business and digital customer experience. And its most familiar application is A/B testing. But the latest advances in AI and machine learning have really improved that process. So I'm going to quickly review this traditional process of A/B testing that you're probably familiar with and maybe have struggled through. And then we're going to talk about how AI augmented approaches can improve each step of this process. So step one, research, investigate, and assess the current state of your customer experience and decide where to improve and what are the specific hypotheses for improvement that you want to test through experimentation. Next, in step two, you need to reserve a portion of traffic for your experiments. This is risky because traffic is precious and you don't want to send traffic to a bad customer experience. But on the other hand, without testing, you have no way of knowing which is the better customer experience and why. Step three, you've got to do all the planning and resourcing and actual coding work to get the experimentation program live. And this includes web development and QA, which are expensive and time-consuming manual processes. Next, you launch your program and you wait. You're waiting for statistical significance. While you're waiting, the test results are somewhat of a black box. You might be watching the performance of your site go down in your analytics platform, but you can't peek at the results of your test, and you don't want to interrupt your test prior to reaching statistical significance, because then you'll lose all your progress and you'll waste that precious traffic that you already spent on the test. Next, you end the test and analyze the results and draw conclusions and hopefully build up your knowledge. Next, you want to take the results away, the best ideas that you validated are making the most impact on your business, and you want to implement them in your underlying your website or digital experience. But the consequences of doing this are significant, right? It locks the experience down into that static state. So if the preference of your customers drifts over time, it'll leave that static experience behind. And then finally, you start the process all over again. Hopefully you've learned something from the last round of testing, and you can apply that to your next batch of hypotheses. But this is very much dependent on the persistent knowledge of the team and the working memory of the people who are familiar with the program, and things can fall through the cracks.
So as Kash says, the whole point of experimentation is that it's a cycle of a process. So we're always learning and we're moving forward. With new data, we have the context necessary to make the next decision. And with that extra data, move deeper in the level of decisions that we're making. And this will progress our experimentation. We'll build up data, act on the data, build up more data, act on that data, just continually and continually improving. And that is the perfect application for AI. Because as you get more data, that data will become more complex, harder to reason over. Now, as humans, we start to fall off and become unable to act on this extra data. But algorithms don't have that weakness at all. In fact, it's the exact opposite. They are relentless. The accuracy and effectiveness of the AI algorithms you're using will get stronger with the introduction of more data. So you're able to extract that additional value that a traditional human-driven experimentation program will leave on the table. So algorithms are set up to model the perfect process. Optimization at scale is a very complex process, especially in a medium or large organization. And to do it right, AI is perfectly set up for this.
That's right. So in taking each step one at a time, number one, in deciding where to begin, optimization teams often start with a set of tried and true ideas that they're very confident will drive early uplift. This usually includes basic ideas about the design or layout of the page. And there's nothing particularly wrong with this, but the set of possible ideas just aren't as wide as when you're working with an AI-powered system. So you're less likely to find the truly highest performing version of the experience. And you're going to run through that limited set of ideas pretty quickly. To generate the highest number of high quality ideas, you need more visibility into the existing customer experience. So you want to collect a lot of data about how customers are interacting with your digital experience. And AI-powered systems are great at doing this because of the robust data pipeline that comes along with this kind of system. So rather than your ideas being limited to UI tweaks that focus on reducing drop-off, your ideas can include more complex hypotheses, like orchestrating a different order of pages as the customer flows through the end-to-end funnel, or deciding to target one audience segment with one version of the customer experience and a different audience segment with a different version. And the specific experiences can get much more granular. So rather than just comparing page A to page B, AI-driven multivariate platforms can isolate the performance of individual variants because AI can handle the data at that scale, something a human team can't keep up with. These AI systems really help you to understand the full context of the experience across all touch points and how different versions of it are performing with significant segments of the population. And being able to access all that data unlocks a much richer idea space. So that's step one. Step two, go ahead.
Thanks. So when you're reserving traffic for an experiment, so traffic is valuable. It's the source of income for a website or digital experience, but also in customer experience optimization, it's a way to learn about your users. So how can we use that traffic with customer experience optimization? So at one end, there's insights. So that's very important for understanding the user, and therefore it's a source of long-term growth. It's very much where the A/B testing piece is focused. It's very, it's giving you conclusions as to which hypotheses are correct. But there are other approaches that exist, things like multi-arm bandit testing. That's more designed for driving uplift in the short term. It's less focused on insights. So what multi-arm bandit is essentially it's a form of dynamic traffic allocation. It will try and identify higher performing experiences and send more traffic to them. But there are some complexities with analysis of the data with this approach. So specifically, there's a phenomenon called Simpson's paradox, where if you have a system where there's a changing behavior in the underlying users, it can lead to incorrect conclusions when comparing performance across that whole period. For example, if your website is having a sale in week 1 and then not in week 2, you're going to have a much higher conversion rate in the first week. But if you shift the proportion of traffic across experiences over those 2 weeks, then you can actually end up with completely incorrect conclusions as to which is the better experience. Now, how can AI help with that? So it can take away the need to pick from focusing on insights or performance. So by using an AI-driven decision-making platform, it can route traffic to drive performance. Now, the kind of scale required for this level of frequent decision-making isn't something that's particularly achievable by humans. At the same time, in the background, the algorithms are analyzing the data to deliver the insights for those long-term insights for driving your experimentation program forward. And as this data is collected, you're getting more and more data back to that initial set of deep learning algorithms, which allows you to uncover trends in smaller and smaller groups. And what this can do is it can unlock personalization opportunities for identifying where there's a group that needs to be optimized for differently than the average, while still driving the performance of the average user up on the website or digital experience.
Right. So step 3, resourcing and coding. And the key thing to know here is that initialization is expensive, not only with web development, time and QA resources, but also with traffic and time in general. You want to get the system up and running as quickly as possible so that you can start seeing results and getting ROI. But when you're starting from scratch, you have very little data to go on to make decisions. So with traditional non-AI approaches, you're very limited in the number of ideas that you can run at one time. So you have to be very selective because those ideas run in isolation, each with their own traffic allocation. With the traditional approach, if you want to launch more ideas, you need a lot more traffic. But the nature of experimentation is that there's a spectrum of ideas and they're not all going to be better than control, but maybe there's a configuration out there that provides the best performance. And so you want to be searching across as wide a space of potential as possible to find it. So through these machine learning approaches, you can run more ideas right from the get-go because they're using the traffic so much more efficiently. So you don't have to be so cautious about selecting only a small number of ideas that you're highly confident in. You can throw all your ideas into the hopper and the system will automatically promote the good ones and hide the bad ones. And it'll use the minimum amount of traffic necessary to do so.
Now, so launching the test and waiting for statistical significance, this is kind of one of the core areas where AI is really bringing home advantages. So traditional methods are very focused on statistical significance. Now, to describe very briefly what that is, it's essentially declaring whether or not 2 experiences are genuinely performing differently, or if their performance is so similar you can't distinguish between them. So this approach comes with a measure of your chance of being wrong. So 95% is the standard. Now, what that means is that you would expect to see significance between 2 different experiences, and 5% of the time, you would be incorrect about that. Now, improving that level of accuracy is not a linear thing with traffic. If you were to move from 90% statistical significance to 95% confidence, that will actually require doubling the traffic for that relatively small gain. So it's important to note that built into experimentation is an expectation that you are going to be wrong some of the time. At 95% confidence, you can expect to be wrong 1 in 20 times, even if everything is running perfectly as you'd expect. So because of that, each individual decision requires a lot of traffic. That's because the consequence of being wrong is so high. Once you decide to lock in a winner from an experiment, you have to take the task, get it implemented in production. That means getting it onto the developer work queue. It needs QAing, it needs deploying. And then once that's been deployed, that decision's locked in for a very long time. So you really don't want to be wrong. Now, where AI comes in to help here is that automating decisions means we can make far more frequent decisions and take more frequent actions on that data. And what that does is it minimizes the risk of each individual decision, because they're easily corrected if they're wrong, because the system itself is shifting back to where performance is best. So as a result, we need far less certainty for each decision, and that means far less data for each decision. So imagine betting $100 on the coin toss. So even if this coin is weighted in your favor, you are putting a lot of risk onto one decision. That's the A/B testing approach. But imagine breaking up that bet into 100 individual bets of $1. So we've reduced the risk of each single bet. And because this is a weighted coin in our favor, we're actually pretty much guaranteeing that we're going to come out ahead because we're making so many decisions where the odds are in our favor. But again, as I mentioned before, this is all about scale. If you're making that level of decision and changing where traffic is being sent to which experience at that scale, then that has to be done automated. It can't be achieved at a human level. It's just not the ability to change things that frequently. And that's where AI is critical in order to be able to unlock this.
All right, so next, step 5, you're closing the test and taking the results to analyze them. And you've been running the test, hopefully getting to statistical significance, and maybe you've been watching performance suffer, right? Maybe you're losing money on bad ideas and you're wasting traffic on proving that they're bad ideas, but you have to wait to complete the test in order to gain statistically significant insights. It's not fun. The traditional workflow, it requires you to stop the test in order to understand the results and take action. But with an AI supported platform, insights on what's working and what isn't are available much sooner. And so you can decide to take action on those insights during a live running project without the problem of what's called peaking in traditional systems. And at the same time, and even more exciting, is that the algorithms are working on this process continually in the background. So they are actively and automatically performing decisioning in real time. In other words, rather than testing and waiting and manually analyzing, gathering insights, and then deciding and acting on those insights as a team, there's a much tighter feedback loop between gathering results and then acting on those results. The system is able to collect data on what is the behavior of the user in the funnel, and then it's able to immediately start to provide the experience with the highest probability to satisfy that visitor, given the data that it's been seeing across all visitors and all experiences very recently. It's making hundreds to thousands of micro decisions and learning as it goes, all minute to minute.
So this large number of decisions means that the system is more responsive to change. Audience behavior changes. Even A/B testing programs will not assume that the uplift from an implemented winning idea is going to last forever. Generally, it will be discounted to the point that after 1 year, there's assumed to be no uplift from that implemented idea. Additionally, the agility of the system means that step 6 of implementing results and starting again afresh is not required because the system itself is continually searching for the best experience. Now, you can take the learnings away and implement them if you want, or you can keep the system running and add and remove content and let the system continue to decide and deliver the best experience. And it's collecting this data over time that opens up another technique for using these learnings. So Bayesian statistics is essentially a form of statistics that allows you to influence your analysis with what's called a prior. Now, prior is a pre-existing view of how the world works that can inform your conclusions. Approaches that aren't able to use this pre-existing knowledge are inherently at a disadvantage. So for example, a very extreme example is, the moon will disappear every day. If you're just looking at the information from that one day, then you would assume that it's just as likely that the moon is gone forever that it would return again the next day. Next night, sorry. Now, with Bayesian statistics, that would use that prior experience that, well, we've seen it return every night for thousands and thousands of years. So it's very likely going to return that next night. So that's an advantage that you get from not discarding previous data that you've collected. Now, an accurate prior is critical when you're making these predictions, because if you're wrong about your pre-existing view of the world, then it's going to make your conclusions less accurate. Now, this AI-driven process that we've described is continue collecting data about what behavior we should expect. And that's what unlocks the ability to create an accurate prior. And that is what's key to using less traffic to make decisions to improve performance.
So one of the most powerful and effective capabilities that an AI approach unlocks is personalization, or the targeting of specific content to smaller and smaller segments of the audience. How it works is that at the same time that the system is driving up performance by finding the best performing experience for the overall audience, it's also working in the background to automatically detect interactions between particular versions of the experience and particular user attributes. So it's able to recommend targeting those micro segments and to automatically deliver those experiences to them while tracking performance data, all the while to quantify the additional uplift. So in this case, it's finding that Yellowstone is the best hero image for a streaming service sign-up page for the overall audience, but it's discovering that an Entourage hero image works best for the Western region, Yellowstone works best for Central, and Succession works best for East. And it's able to validate and automatically deliver those targeted microsegment experiences. And this, of course, relates to the last step of implementing, because a developer may want to take away a winner and implement it in the core experience, but there's no way that a developer could code in all of these rules for personalization. You're much better off just leaving the experience in the AI-based system and letting the AI discover and deliver those segmented personalization rules. So in summary, the advantage really comes down to the number and speed of micro decisions that the system is able to make, and the fact that those decisions are informed by a vastly larger data set than a human user could ever hope to reason over. And this really works. Similar to the way that Alphago is beating the best Go players in the world, an AI-enabled optimization platform is able to way outperform a typical CX optimization team using a set of traditional A/B testing tools. It's just not even close. So that is everything we had to show you all today. And I'll pass it back over to Maren.
Thanks so much to both of you for joining us today. Check out Think CX episodes 1 through 17 at evolv.ai. If you have any recommended topics, please definitely share those at hello@evolv.ai. We check it frequently and love to recycle topics that you're interested in hearing about. Thanks so much and have a great day.